Okay, so this is your notes. Okay, so before I get into the lecture, you have a look at this one. Okay, this ABCD. Which of the following are graph of function? Okay, I will set up a poll for you. Okay, if you think that okay, I will set up a minute. Okay, B, C, D. Just to revise, if you still remember what is function. Okay. 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 So you go to the general tab. Maybe you need to exit. Then you go to the general chat. Then you go and vote. If you think A is a function, is a graph of function, then just click on A. If you think B is a graph of function, then you click on B. If you think C is a function, then you click on C. If you think D is a function, then you click on D. Okay, I give you 1 minute to decide. Okay, so most of the people vote for A and C. Yeah, great. Just make sure. I want to make sure that you remember what is function. Okay, we have 4 people voting for A and C. Okay. Some more. Moderator, you need to tell them what to do. Just click on the A, B, C, D at the bottom. Okay, so before I tell you the answer, let us revise what is function. Okay, so function, the concept of function, if you learn in the Form 4, you should remember. It's like, yeah, you can select more than one because there are actually more than one answer here. Okay, there are more than one answer here. Okay, so let us revise the concept of function. Back then in Form 4, your teacher taught you that, maybe your teacher teach you differently, but usually I'll remember like this. You have an X as your input, okay? X. Then this is your, then you have something like a machine, and then you call this machine F, okay? Then you put the X into the machine, you get an Fx, okay? So for example, imagine that X is an apple. You put and this F is maybe a blender, okay? It's a blender. You put an apple into the blender, then you get apple juice, okay? You put an orange into the blender, you get orange juice. You put a grape into the blender, you get a grape juice. So this blender will always do the same thing to whatever you put into the blender. Okay, you will put human, you will get human juice or whatever. You put chicken, you will get a chicken juice or whatever. Okay, so this is a concept of function. It's like a machine that will do the same thing, but you will have different output. You may have different output to whatever you put into the machine. Okay, so basically it's like your before and after. Okay, before it's x, and after that you will write as f of x. Okay, so now which of the following are graph of functions? Okay, a lot of people are voting for A and C. Okay, A and C. B and D only got 1 vote. And yeah, you guys are correct. Only A and C are graph of functions. Because if you refer to the definition of functions, which is here, your fx must be unique, which means you, for one input, can only have 1 output. Okay, so this is a definition of function. So if you have a look at this ABCD, and if you go a little bit, maybe your chapter 1.0 in your MF, you learn about relation, right? What kind of relation is A? It's a 1-to-1, isn't it? 1-to-1. What about B? It's for 1x you can have 2y, which means it is a 1-to-many. Then what about C? Okay, maybe for 2x value can have the same y value. This is what we call, maybe I shouldn't draw. Okay, this is what we call many to 1. And lastly, you see one x values can have two y values, and one y values can have two x values, which means that this is a many-to-many relation. Okay, so from if you can determine what kind of relation the graph is, then you should be able to tell whether the graph is a graph of functions. Because by the definition, I told you that the output must be unique. One input can only have one output. If you put an apple into the blender, you can only get an apple juice. You cannot get apple juice and orange juice. Okay, that is not a function. That is not a blender anyway. Okay, so with that, you just have to notice that you just have to take a note at this one. This is your input. This is your output, right? As long as your output is one, you only have one output, then they are functions. They are graph of functions. But what if you tell me, okay, by the way, I think you can fill in the blanks already. Only one-to-one and many-to-one. Many-to-one relations are functions. Okay? But what if you tell me, hey, I'm not really good with this relation. I don't know how to determine what relation they are because I'm not in a relationship maybe. And I have an easier solution for you. You just go ahead and go to the graph. Okay, you just go to the graph, and you just take a pen or whatever. You don't even need a ruler. Just go to the graph. You just simply draw vertical lines. Just simply draw vertical lines. And that is okay. Anywhere you like, just random vertical lines. Okay. So if for all the vertical lines you draw, they only intersect maximum once with the graph. You see this one don't intersect at all, right? Then it is a graph of function. One more time, you have to look at this one. You see, look at this vertical line. It intersects with the curve for 2 times, right? This line intersect 2 times. This line intersect 2 times. So this is not a graph of function. Okay. Then what about this one? You see? Oh, this one don't intersect. This one intersect once. This one also intersect once. This one don't intersect. This one don't intersect. Maximum intersect once. So this is a graph of function. This one intersect twice, intersect twice. So this is not a graph of function. Simple, isn't it? So this is what we call as vertical line test. Vertical line test. So basically, this vertical line test is to test. You see, you just try to make sense of it lah. For whatever vertical line that you draw, is from one input, right? Okay, one input. One input can only have one output. One input cannot have 2 outputs. One input can only have one output. One input cannot have 2 outputs. Okay, so this is the idea behind vertical line test. So basically, you just go ahead and draw any vertical line. Then you can only have maximum of 1 intersection with the curve. Then we say that it is a function. Okay, so example of functions you have a lot. It's like you have your logarithmic function. Okay, your log is actually a function. Your trigonometric function, obviously, and even your differentiation. Even your differentiation is a function, you know. Okay, it's like a function you put in the original equation, then you get the gradient function. Differentiation, the derivative is a function. If differentiation is a function, means integration is also the function. Integration is also a function. Even though you might want to argue that, hey, you know, for integration we have a plus c at the back, right? Isn't it changing the outputs? But what I will tell you is your c is always constant. It's always the same thing. Just that you don't know the value. So you will always only have one output. Okay. So these are all the functions that you will learn in the future. Okay. Okay. Finally, you will get to the second one, which is range and domains. Okay. So if you remember back then in your SPM, your teacher tell you that, oh, you know what, we have like 2 sets. Okay, so set A to set B, and then your set A maybe is your domain. This is your core domain. And then you have your object A, B, your image C, D, E, something like this, right? Then or A will maps to C under function F, B will maps to, okay, maybe B maps to D. So these two fella here, A and B are your object, and this C and D are your image. And then what is your range? Your range is whatever thing in your domain that have an object. Okay, basically just a revision for your range of domains. Okay, but when you go to a higher level, you need to know how to write range and domain properly. Okay, so actually, you know what? You know, when you learn about functions, right? It's all about set, from one set maps to another set. So actually, everything you are write in set notation. If you still remember your set, okay. So if you can see here, yeah, we are using braces which are like elements in a set, right? And usually, okay, of course, you have multiple ways of writing this. What you need to remember, okay, if you refer to this table, and all you need to remember is, if it is like round brackets means open interval. Open interval means not include. If you look at this one, round bracket, open interval, see, not include A and B. And if you draw the inequality, you see you are using a white dot, right? Okay, it is an empty circle. And if it is square bracket means include. Okay, you see, square bracket, include, and there's a closed interval. You'll use solid circle. Okay, so this is how you write a notation, and of course you can have a combination of that. You can have like this, you can have like this. Okay, so this is how usually people write this for notation, for the range and domain notation. Both we are using this kind of notation, and some books, and I think for SDPM, they will prefer people to write like this, to write in set description. Okay, set description basically means like, it's like if you remember you have A like this, A, B, C, D, blah blah blah. Means, okay, when you learn your set, this one means A, B, C, D are the elements of set A, right? So basically what this mean, especially this vertical line means, is all x given, okay, you read this as given that x is in between A and B. One more time. I want to find maybe the domain of fx. And I write this. Then I write this, meaning my domain is all the x values given that A is in between A and x is in between A and B, non-inclusive. Non-inclusive means not include. For this one, you say, oh, inclusive. In between A and B, inclusive. So it's all about notation. Okay. So moral of the story. When you write brackets, right? When you write this bracket, right? Make sure you write properly. Don't write something like this. Is it a square bracket or a round bracket? Just to make sure that you be very, very careful when you write in this kind of notation. Okay. And of course, you can write this one. You can of course write this one. Okay. And another thing that I want you to take note is, whenever you have infinity, you must only use round brackets, because you cannot include infinity in your either range or domain. Both you can't include infinity, because infinity is not a number. If you can include infinity in your set, in your domain, then you can just get your calculus book, your whole semester 2 books, you can throw it away already. Okay, so because the whole concept of calculus is study about infinity. It's about limits, your approach, right? Your integration, the area under the graph you go and split into infinite many rectangles. If infinity is a finite number, that means all the concept of calculus is wrong already. You can throw it away. So you should never write a square bracket for infinity. Okay. So this is about how you write stuff. Okay. So now we'll do a simple exercise. We need to determine the natural domains of the function. Natural domains basically means where the function is defined. What do I mean by defined? Okay, you have a look at this function here, right? It is like a fraction of 2. And when you see a fraction of 2, when will the function be undefined? Okay, I'll give you right now a note here. It is undefined. It is undefined when the first condition, if it is like, okay, gx over hx. If your hx is equals to 0, then the whole function is undefined, right? Back then in your SPM, you also need to restrict the domain, remember? So your hx cannot be 0. And another thing that you want to take note is, you know that if you have something, okay, maybe what should I do? Okay, Rx, okay, something under a square root. Your Rx cannot be negative, isn't it? You cannot take square root of the negative number unless you want to go to a complex form. Okay, so Rx must be greater. Can it be 0? Yes, it can be 0. Must be greater or equal to 0. So with that, you can actually form two inequality. Actually, it's not an inequality to see where is the domain. Okay, so for this first one, we need to make sure that this fella here, we need to make sure that it is not 0. So what we do, we let it be 0. We let it be 0 first and see what x values, will give us a 0 in denominator. Okay, we let it be 0, then we just move things around. This will be x squared minus 9 equals to 4, x squared minus 9 equals to 16, x squared equals to 25. So x equals to, remember, plus minus. Yeah? Whenever you take a square root, you need to take into consideration both plus minus. So if you put in plus or positive or negative 5 into the equation, you will get the 0 in denominator, right? You can just try it on the order. You see, 25 minus 9 is 16. Square root of 16 is 4. 4 minus 4 is 0, right? So I will write this as, okay, all the x not equals to negative 5 and x not equals to 5. Okay, you write the condition at back. Okay, this one you read as all the x given that x is not equals to negative 5 and x is not equals to 5. And this is to avoid you get a 0 in the denominator. Then what about square root? This is to avoid that you get a complex number. So you just let this x squared minus 9, it must be greater or equals to 0, right? Greater or equals to 0. And don't go and shift this like this. X squared minus 9 greater equals 0, x squared greater equals to 9. Oh, you know what? X greater equals to plus minus 3. This is nonsense. This is nonsense. Because why is it nonsense? Because remember when you have a negative in front of an x and you want to shift it to the other side of inequality, you need to change the sign, right? From more than equal, you need to change it to less than equal. So you can do it like this. Do it properly, like how you did in your SPM. Just go ahead and this. Okay, maybe I write one more step for you. X plus 3, x minus 3 greater equals 0. Go and sketch a graph. Your negative 3 is here, your positive 3 is here. You want the region that is greater than 0, including the line itself. So x should be smaller equals to negative 3. X should be greater equals to positive 3. Okay, so maybe I should write this x. Okay, so now we have defined, okay, so meaning to say that when x is in between this region, right, you will get undefined fx. Okay, but do you notice that this fx is actually, you need to take into consideration of both conditions here. So you just go ahead and find the intersection between these two sets. Okay, remember I told you all the elements, or whatever you want to talk about, whenever you talk about function, branch and domains of function, they are set. So I want to fulfill both conditions. I want to fulfill both this and that conditions. So my domain is the intersection between these two sets of value. So at the end of the day, what you will write is the domain is all the x given x not equals to negative 5, x smaller equals to negative 3, then x greater or equals to 3, x not equals to 5. This is one way of writing it. You can also use this square bracket and round bracket thingy by writing the domain is from negative infinity can, right? And don't include negative infinity, yeah? From negative infinity to negative 5. Can you include negative 5? Cannot, so write a round bracket. Union from negative 5, cannot include, yeah? Cannot include negative 5 to negative 3. Inclusive. That you tell me, oh, I know. Union from positive 3 inclusive to 5 non-inclusive. Union from 5 non-inclusive to positive infinity non-inclusive. So this is another way that you can write your domain. Okay, any question? Is everyone okay? I think we will go over time. Okay, so if you're okay, then we move on to range, and range is actually simpler as long as you know the domain. And for this question particularly, you know that you can submit any value for x. You will not get negative here, right? Because whatever number you square, you will get a positive number. This is why just remember, whenever you have your you take square root for a square, this is not equals to x. Now this is wrong. This is correct. Absolute value of x. Okay, so if you square anything, you get a positive number, which means this will always be positive, this will always be positive, and if this 9 plus x squared is always positive, then you don't have to worry about your domain. Your domain will just be from negative infinity to infinity. Okay, then what about the range? The question is asking about range. So this one you need a little bit of logical thinking. Okay, what is the minimum? What is the minimum of this piece here? Because only this piece will have your x, right? If you put in negative infinity, you'll get 9 plus infinity square, which is still infinity. Infinity you square root, still infinity. Okay, so if you put in negative infinity, you'll get infinity for y. And if you put in just now was negative infinity, if you put in positive infinity, it will also be the same thing, right? So what is the minimum of this piece? Put in 0. When you put in 0, what happens when you put in 0? It is 9 plus 0, square root, it is 3. 2 plus 3 is 5. So the minimum of this y is actually 5, which is 2 plus 3. Okay? It's a little bit of logical thinking like that. You say, oh, this one will give me what, this one, that one will give me what. Then what about the maximum? Maximum, just like I told you already, you put in infinity or you put in negative infinity for x, you'll get the whole thing equals to infinity. So the maximum is obviously positive infinity. So the range of this function here should be 5 infinity, include or not? Yes, include 5. You can get the 5, but not okay, you will not get infinity, but you cannot include infinity. Okay, is everything clear? Is everyone clear? And moderator, if you are free, can you do me a favor? Can you go and get the graph of this function? They will just send it send in the general text. Just go to the decimals for this function. 2 plus square root of 9 plus x squared, so that they can see where is the maximum. What do I mean by minimum? Moderator, please do me a favor, yeah? Y equals to 2 plus square root of 9 plus x squared. Okay, so meanwhile we'll move on. We'll do a quick revision, a very quick revision. Okay, we are almost done. Okay, we have like 6 more minutes. Maybe we need to drag to 3 or 5 before for this 1.1. Okay, composite function. Composite function you learn in your MF, right? It's like a It's like you put your x into the first machine, you get your x into the first machine, you get the first output. Then you put this output into the second machine, then you get the final output. Just like, okay, maybe you initially you have an apple. Okay, apple. I always like to use the example of apple. You put into a blender, you get apple juice. Get apple juice. Then you put this apple juice into maybe your apple juice is here. your apple juice. Then you put your apple juice into a freezer. Then you get what? You get a, I don't know what you call it, popsicles or ice cream or whatever. Okay, popsicles. Okay, something like that. So the concept is like, you put your eggs into the first machine, then that one put, then your output of that one put into the second machine. Okay, so just a little bit of revision. When you write FGX, means you have to find which one first. You need to find GX first, right? So this one basically means F of GX is what? Sin X equals to, then you just replace all the X with sin X. I don't know what this crazy stuff is. Just like sin X to the sin X plus 2. You don't care the function here. Don't worry. Okay, we have our graph here. If you are, yeah, if you want to, okay, let me just go to the graph. Yeah. So you see this one at this point is actually 5. Okay. You can just click on the one, click on the link. Yeah, you can see this one. I mean by negative. Sorry, the minimum of the graph, and it will go up to infinity. Okay. So coming back to this one. What about GFX? GFX, you will find fx first, then you put into g. You already got fx. Just put the whole thing into the x here. So it is sine of x to the x plus 2, whatever it is. I don't care. Okay. So yeah, I go through this composite function very quickly because you have learned it in your SGMF. And what I want you to take note on this composite function is again the range and domain. And obviously, the domain of this function here, FGX, the domain of it, you need to make sure that it is still defined, it is still in the domain of F before you're putting into the second machine, right? So it seems like, okay. You need to make sure that this is something that you can put into the freezer. Okay? And in the order to make sure that, you need to make sure that this whatever fruit that you put into the blender can produce something that you can put into the freezer. So basically it means your first output must be in the domain of the second function, of in this case is our f. So the domain of FGX, I'm writing short for the domain. Okay, this is not differentiate. I mean domain. The domain of FGX is the x values. The domain of FGX is the x values that will give you an output that is in the domain of F when it undergoes function G. Something like that, like whatever you want to phrase it. Just the most important thing is you get the idea. Okay? You have to make sure that your X will produce an output after the first function. That output is in the domain of the second function. Okay? And that X is in the domain of this composite function FGX. Okay? And now, another revision, inverse function. You know that when, function f maps a to 3, then if we have another function maps 3 back to a, then this is the inverse of f, right? So this is the concept of inverse function. But not all the functions have inverse function. Because if you go back to the relation, this one, where was it? This one. You see, if you inverse it, okay, we don't care about this one anymore. I don't look at this two anymore. If you inverse it, you go and inverse a 1-to-1 function. It is still originally it is 1-to-1. After you inverse it, it becomes still 1-to-1. But for many-to-1 function, the original function was many-to-1. Yeah, nothing wrong. It is a function because only have one unique output. But the inverse of it is 1-to-many. Something wrong, right? Your output becomes not unique, which means actually the if you go and sketch the inverse of this one, I think it will look something like this. And you're going to draw a vertical line, test is going to be failed. This is your F. This is your f, this is your f inverse. So we cannot call this a function, okay? So with that, we can draw a simple conclusion that only one-to-one function, only one-to-one functions have inverse functions. Okay? And you should also know the graphical properties that f and f inverse are always symmetrical about the line y goes to x. It's like a reflection. Why? Because for inverse function, basically what you do is you switch your x and y. That's all. Your fx is 2x. Okay, your y equals to 2x. Then your inverse is x equals to 2y. And y is what? Y is what again? Half x. These are inverse of, these are f inverse, these are f. Isn't it? You just go ahead and shift to switch your x and y. This is a more simpler solution, more simpler explanation for inverse function. And if that is true, if it is true that f and f inverse are symmetrical about the line y equal to x, then what test can we use to determine whether a function have an inverse? Okay, originally we are using vertical line test, right? And if you go and reflect this vertical line on y equals to x, you will get a horizontal line. So we will be using horizontal line test, horizontal line test to detect whether the function has an inverse function. And just now for vertical line test, we draw vertical lines. For horizontal line test, we just go ahead and draw horizontal lines. Okay, come back to this one again. It's pretty messy. Let me just erase the whole thing. Okay. See, yeah? I draw horizontal line. See? One intersection, one intersection, one intersection, one intersection, no intersection, no intersection. How about this one? Oh, two intersection, cannot already. Two intersection, no intersection, no intersection. So it's exactly the same procedure as your vertical line test, just that you are drawing horizontal line. If there is more than one intersection per horizontal line, means this is still a function. These functions do not have an inverse function. No inverse function. But here's the thing. Just give me some. I just want to talk about this real quick. Remember your sine graph now? Something that is right. Definitely it will fail the horizontal line test. But we still have sine inverse, isn't it? So this is when the mathematician they purposely I want the sine inverse no matter what happened. I just want the sine inverse. So what they did is actually they restrict the domain. I said, oh, let's say we only look at this part of this. Okay, not include this one. Look at this part of sine function, sine curve, and I draw the vertical line, horizontal line. Sorry. Oh, okay. Sorry. For sine, they actually, because your graph is like this, right? It's like this. They actually take from here to here. Okay. If you don't care about this one, don't care about this part, then you see, oh, whatever vertical line test I draw, horizontal line test is still. Yeah. Sorry. I'm really sorry about that. I highlight the wrong part. Okay, from here to here again. I take from here to here only. From here to here only. I purposely go and define my f to be like that, so that I will not fail my horizontal line test. So this is the importance of range and domains. This is why you need to know the concept of range and domain. Because when you go to chapter 1.3 or 1.5, I forgot which one. I think it's 1.4. You learn about trigonometric functions. You will learn about inverse trigonometric functions. Then you need to understand why do they restrict the domain. Okay? And another thing I think I just now forgot to mention, the domain of f is the range of f inverse. The range of f inverse is the domain of f. Okay, and this one is some of the basic important identities that involve inverse function, which I got from my SPM books. What's it? Okay, I just go ahead and copy it here. So I don't think I have time to prove it one by one, just to make sure that you know that exists and just make use of them. Especially this one. Especially this is super important. This is super important. Okay. Then last thing, okay. Oh, finally we have something new, right? Piecewise defined function. Okay, we'll go through this. Maybe give me five more minutes. 5 more minutes. Yeah. Piecewise defined function basically means it is a function that is defined differently on different part of the domain. It is a function that is defined differently on different part of the domain. Means what? I give you an example. Okay, I give you an example. Let's say we have this is your edge. Okay, you all are now almost 18 already, right? Okay, it's okay. Then this is the maybe an ang bao function. Sorry about if you are not Chinese, just bear with me. Okay, so we have a ang bao function and ang bao function. Okay, against your I go and plot the ang bao money that I get against my edge. Okay, so when you are just a baby or everyone know, oh, you have a newborn baby, we gave you ang bao, whatever, you have a lot of money coming in. But after that, because at 2 years old, you because you are still a baby, right? So you don't follow your parents for visiting. So you stay at home. So you get less ang bao. Okay, maybe drop a little bit. Then after you maybe starting from 5 years old, you can work already. Then you follow your parents, go to your relatives' house. Then you starting to get your ang bao. Oh, then increase again. Then after that, you get older, get into secondary school. You go and visit your friends, and your friends' parents they give you ang bao, so you get more ang bao. But until the age of 18, all your relatives tell you that, boy, you are now an adult, so you don't give ang bao anymore. So immediately your ang bao, your income during your Chinese New Year becomes zero. Okay, so this is like funny, just a funny piecewise defined function. Okay, so it means like from 0. Okay, I will write this one. This is my ang bao function ax. Maybe this is like x cubed plus 2x whatever function, I don't know. Okay, it is defined. This curve is defined by x cubed plus 2x blah 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 whatever it is. When I was 0 years old to 18 years old, not include 18. The moment I celebrate my 18th birthday, I get no ang bao. So it is 0 starting from 18 onwards. Or okay, maybe I should write x greater equals to 18. So do you notice that this is actually a domain? This is how you define a domain, right? Which means, so this is the definition of piecewise defined function. On different parts of its domain, it is defined differently. Before 18, you can get ang bao. And then ang bao is sometimes you get a lot, sometimes you get no ang bao because you don't go visiting, something like that. Then after 18, immediately, okay, you are an adult, we don't give you ang bao anymore. No more ang bao. So immediately becomes 0. Okay? So you can say that even though they are not like continuous like that, they are still the same function defined by this ang bao function. Right? They are still called the same function, still the ang bao function. Just that they are defined differently using different equation, different formula, at different part of the domain. So this is what we call piecewise defined function. And okay, I have 2 more minutes. Okay, so a very, very common piecewise defined function that you should know is the absolute value functions, which are like that. When x is positive, then x is just y equals to x, right? And this one, okay, actually this is redundant. You can actually ignore this one and give it to one of them. Okay, then what happens when x is negative? When x is negative, originally if you just draw the line y equals to x, is originally supposed to be like that, right? But you want to flip it. Initially it is -1. When x is -1, y is supposed to be -1. But I want to flip it. How should I flip it? Just put a negative in front, no? Negative of -1 become +1, which is here, which is what we want. So I just define, you know what? When x is negative, the function is defined by y equals to -x. Okay? So absolute value function is the most common piecewise defined function that you will encounter in your life. Piecewise defined function. And of course you have other common piecewise defined function, including the greatest integer function. Okay, I just go through this very quickly. Greatest integer function, basically, you also call it floor function. Again, make sure you draw your brackets or whatever properly. You see this one is without a ceiling. This x don't have head, don't have any head, only have floor. So we call it floor function or floor integer function, whatever. Okay, greatest integer function basically the meaning of greatest integer function means it is the greatest integer smaller or equal to. Meaning, when let's say I have a 1.5 is here, I will go to the greatest integer smaller or equals to 1.5. Again, the greatest integer, you know what is integer, right? -1, -2, -3, 1, 2, 3, okay? The greatest integer smaller or equal to 1.5 is 1. Then what about 2? Okay, when it is 2, then when it is 2, then immediately the greatest integer smaller than 2. The smallest integer greater or greater. The smaller integer greater or equals to 2 is obviously 2. This is your greatest integer function. And how you remember? You just imagine greatest integer function is just like your edge. Okay? You guys are 18 or 19? 18, I think it's 18, right? So you just imagine, okay, this is year. This is your edge. 20, 20, 20, 21, 20, 22. Okay, you are 17, 18, 19. Okay? So from 2020, the moment you celebrate your birthday or the moment you celebrate New Year, whatever you want to define it, you are 17 years old. Right? Until December 31st. Then, the moment you celebrate New Year for 2021 New Year, you become 18 years old or birthday, up to you, however you want to define it. Okay? The moment you celebrate your birthday, okay, whatever, you become 18 years old until your next birthday. Then the moment you celebrate your next birthday, you become 19 years old, and so on and so forth. So this is like a concept of greatest integer function or floor integer function. Okay? Then if we have greatest integer function, we will have least integer function. Okay? Least integer function is the opposite of greatest integer function, which is the smallest. Greatest. I meant to write greatest, sorry. This is least integer function means the smallest integer greater or equal to. Okay, you see? When it is, let's say this time we will look at negative, negative 2.4, something like that. The smallest integer greater or equals to negative 2.4 is negative 2. Greater, Again, look at this one. Okay, 2. Maybe 2.7. 2.7. Okay, 2.7. The smallest integer greater or equals to 2.7 is 3. Okay. So one way of remember least integer function, or just now was what? Just now was floor. So this time it is ceiling, the ceiling function. Ceiling integer function. It's like your parking ticket. It's like your parking ticket. You see, the moment you get into the shopping mall, you get into the parking lot. Okay, you have to pay. Okay, this is a 0.1 second. The 0.1 second you get into the parking lot, you need to pay 1 ringgit already. Then on the 0.99 hours, maybe the 59 minutes that you are in the parking ticket, you still pay 1 ringgit. But if you get out of the if the moment you get out of the the moment you pass, you pay your ticket it's already the second hour. The second hours, then you have to pay 2 ringgit, something like that. So this is the concept of least integer function or ceiling functions. Okay. So now we do a very simple exercise. We need to find a formula for the graph of function, which means we define differently on different parts of the domain. Okay, and for this one, it's actually very easy. Fx equals to, you see that we actually have how many sections, how many parts? 1 part, 2 parts, 3 parts. So we need to define, we need to write 3 formulas for each one of them. Okay, so for the first one, it's actually from -1 to 1, include -1, right? But not include, sorry, this is 0. From -1, I think, okay, I will have a break after this one, okay? After this 2 questions, okay? So when your x is in between -1 and 0, include -1, not include 0, your x is defined by, this is a straight line, isn't it? This is a straight line. If you go and find the gradient, y equals to mx plus c, intersect at 0, I think this is equals to -x. I think so. You just go ahead and do your y equals to mx plus c. Okay? Then when it is in between 1 and 0 and 1. It is in between 0 and 1. 0 and 1. Include 1, right? Then what is the value of y? It's just 1. Then what about this part? This part also is a straight line. You go and do your y equals to mx plus c. And this one is, if you extrapolate, I think this is 1, means this is 2, this is 1. Okay, so it should be -half x plus 3 over 2, right? I think so. If you guys go and check, I'm not sure about that. I think it's -half x plus 2. When x is in between 0, 1 and 3, not including 3. And you actually have another answer for this, because if you notice that this point here, you can use this definition, will give you a 1. If you use this definition, it will also give you a 1. So you can either write it like this, or you can give the equals to this one. Doesn't matter, as long as you get the values on given in the graph. Okay, and we do this very quickly. Okay, this one is again fx equals to -x. From this one is from what? Far away. Far away is -infinity. And you don't actually have to write like this. Don't actually have to write like this. You want to include also can. But what if you just write like x smaller than 0 is enough already? Don't have to write a -infinity. Okay? And then from here to here is what? From here to here is a parabola, isn't it? X squared. From 0 to 1. Like I said, you can give the equals to any one of them. As long as when you sub in 0, you get a 0, that's it. And lastly, this one, easier. Y equals to 1. From 1 onwards. Okay, just write x greater or equals to 1 will do. Okay? So this is it for the piecewise defined function, and this is a question that they will usually ask. They will give you either give you a graph, give you a graph, ask you to write the formula, or they will give you the formula, you go sketch a graph. Okay? And we have a past year question here, which I don't have time to discuss. And yeah, we'll have maybe a 10 minutes break. 10 minutes break. That maybe you want to do, if you want to do the question, you can do it during the break. Okay, we'll have a 10 minutes break. Now, but before that, any question?